Having already discussed numbers in measurements, that is magnitude and errors associated with those magnitudes in measurement, let's now shift our focus to the units in the measurements. In these next couple of discussion sessions, we will talk about units, different systems of units. We will also talk about how to use units in calculations, and more importantly, dimensional analysis. Dimensional analysis is a unit conversion methodology, a strategy, is very important for this entire course, because this is where we will set up a problem solving strategy that we will try and use throughout the quarter and maybe even beyond. So this is a very important section in this course, and then we will go into discussion of density and using that as an equivalence factor or a conversion factor, and then talk about temperature units as well towards the end. Okay, so what are units? Units are labels that describe a property that is being measured. For example, when you say 10 grams, grams is the unit which tells the reader that the property is being measured is mass or weight. When you drive at 35 miles per hour is the unit which gives the speed of the vehicle you're driving. So units are very important because they are a label for the property that is being measured. Units are extremely important. Without units, a measurement is incomplete. For example, if I say that I weigh 120, now that's a very incomplete information because the reader doesn't know whether it is 120 milligrams or grams or tons or pounds or ounces, and it's a very it's not correct to not give a unit for a measurement. Without a unit, a measurement is incomplete. Units are also very case sensitive. A lowercase g is not the same as an uppercase g, or an uppercase m is not the same as a lowercase m. A g, when we write a unit as G, is not the same as a unit GAL, because G is grams but GAL is gallons. M is not the same as MIN, because M is meters whereas MIN is minutes. So we have to be very careful as to how we write the units, because units are not only case sensitive, they are also symbol specific. So units are extremely important and we need to pay attention to the units. There are two different systems of units that are being used. One is the English system, or the SI system of units. This is a system that we use in our everyday lives in this country. For example, when you go to buy milk at the grocery store, you buy in gallons or pints. Or when you buy potatoes, you weigh those in pounds. When a baby is born, their weight is measured in ounces, pounds and ounces, so on and so forth. But the scientific community, on the other hand, uses the metric system, which is completely different compared to the English system. We need to be comfortable with both of them. We need to be able to use both of them and also be able to convert between the two. And that is something that we will focus on in this chapter. Dimension analysis is a system where you convert one unit of a property into another unit of that same property. So we'll get back to that. But let's briefly discuss the metric system. Our discussion is, again, just a review, hoping that you have studied this in your previous classes, and please come and see me if you need more help, or see a tutor in case you need more help. But you do need to become very comfortable with metric system pretty soon. So the metric system of units uses prefixes to represent factors of 10 or multiples of 10 as compared to a base unit. A base unit of every property is given a value of 1, and then various sizes of relative to the base unit are then assigned either a factor of 10 or a multiple of 10. For example, now these are some metric system prefixes that you must memorize pretty soon. You need to know these. So please memorize these. Now, the base unit, as I said, is given the value of 1, that's the standard, and then every multiple of 10 relative to the base unit or factor of 10 relative to the base unit is assigned a certain numerical value. Whether you write that numerical value in a decimal form or you write it in a scientific notation doesn't matter. You could use either of those two, but you do need to know which numerical value goes with which prefix. Now, how do we use a metric system? How do we convert between two units of the same property within metric system? Again, if you are comfortable with metric system, use the method you have learned. If you are not comfortable with the metric system, then my suggestion to you would be to always put a prefix always put a 1 in front of the prefixed unit, and the 10 raised to whatever value goes in front of the base unit. So what I mean by this is, let's take an example of the relationship between kilograms and grams. When you see this, grams is the base unit of measuring mass or weight. On the other hand, kilo is the prefix. So if you're not comfortable with the metric system, my suggestion is use this approach, which says that you put a 1 in front of the unit with the prefix. In this case, kilogram is the prefixed unit. And then the numerical value associated with the prefix kilo goes in front of the base unit. If you go back to the table, the numerical value that is associated with kilo is 1000 or 10 raised to 3. That goes in front of the base unit. Okay, let's try this strategy out a couple more times so you become a little bit more comfortable, and then you will be practicing this constantly, so please get used to this. How about the relationship between moles and millimoles? So once again, first step is to identify the base unit. This is the base unit, and identify the prefix. In this case, the prefix is lowercase m, which is milli. As the strategy said, put a 1 in front of the base unit, in front of the prefixed unit, and the numerical value associated with the prefix goes in front of the base unit. So 10 raised to minus 3 moles equals 1 millimole. Of course, 10 raised to minus 3 can also be written as 0.001. That is totally okay to do. Okay, how about nanometers and meters? Once again, recognize that meters is the base unit, whereas lowercase n nano is the prefix. So using the same strategy, we put a 1 in front of the prefixed unit, and the numerical value associated with the prefix, in this case nano, so minus 9, goes in front of the base unit. Now, for those of you who are very comfortable with the metric system, of course, hopefully you recognize that each of these equations can be written in two different ways. In other words, if 1 kilogram is equal to 1000 grams, you can also say that 10 raised to minus 3 kilogram equals 1 gram. Totally fine to do that. Similarly, if 10 raised to minus 3 moles equals 1 millimole, 1 mole equals 1000 millimoles. Once again, totally okay to do that. And similarly, 10 raised to plus 9 nanometers equals 1 meters. Please switch those around only if you are comfortable with the metric system. If you are not comfortable with the metric system, follow the strategy outlined here in order to not make a mistake. Okay, so some of the common properties that we measure during the course of our study are length. One of them is length. Length is defined as the distance between 2 points. The base unit for length in metric system is meters. Can we use the strategy that we used earlier and write equations to relate these units? Okay, so 10 raised to minus 3, sorry, my mistake. 10 raised to 3 meters equals 1 kilometer. 1 centimeter equals 10 raised to minus 2 meters, and 1 micrometers, this is read as micro meters, equals 10 raised to minus 6 meters. Okay, so these are the base unit is meters, and of course then you can represent the other units as factors or multiples of meters. The common units used in the English system are of course inches, we use feet, we use yards, we use miles, and so on and so forth. Now, I would not like for you to memorize the conversions in the English system. Those will be given to you when you're solving a problem, but you do need to know the metric system, the prefixes in the metric system. Okay. Another property that we commonly measure is mass, which measures the amount of matter contained in a substance. The base unit in the metric system for mass is grams. Go ahead, take a minute and write out the relationships between those equations using the metric system. The English system units of mass that are commonly used are ounces and pounds. Once again, you do not need to memorize the equation between pounds and ounces and grams and pounds. Those will be given to you. You do need to, however, memorize the prefixes in the metric system. We also measure volume, which is the space occupied by a substance, and the base unit for volume in metric system is liters, and I'm sure you can figure out what is the relationship between liters and milliliters. Yes, you're right. 1 liter equals 1000 milliliters, or you can also say 10 raised to minus 3 liters equals 1 milliliter. Now 1 liter is defined as that it is the volume of a cube which has sides equal to 10 centimeters each. So if you have a cube whose sides are 10 centimeters each, its volume will be, what would be its volume? Yes, that would be 1000 centimeter cube, because you're multiplying centimeter, centimeter, and centimeter, it gives you centimeter cube. Now if 1 liter is 1000 mLs, and 1 liter is also equal to 1000 centimeter cube, then 1 ml is equal to 1 centimeter cube. Now this is an equation that you must memorize. You must always know that 1 ml equals 1 cc. By the way, centimeter cube is also sometimes called cubic centimeter. It is also commonly referred to as cc. Okay. In the English system, the common units of volume measurement, of course, are quarts and gallons. Once again, please don't memorize these equations. These will be given to you as long as you know the metric equations. Okay, time is another common property that is measured, and the base unit of time is seconds. Please note that the appropriate representation of seconds is a lowercase s. Time can of course be measured in minutes and hours and days and months and weeks and years and whatever you want to do. So make sure that you know that 60 seconds make up 1 minute, and 60 minutes make up 1 hour. Of course, 24 hours make a day. You can go from there. We also measure temperature. Temperature is the measure of hotness or coldness of an object. Temperature is not the energy contained in an object, although the two are related to each other. Temperature just simply tells us how hot or cold a certain object is. Common units of measuring temperature in the metric system are degree Celsius and degree Kelvin. Excuse me, I apologize. Degree Celsius and Kelvin. Please note that the degree sign is very important for the Celsius scale, but there is no degree for Kelvin. It's an uppercase K without a degree sign. And of course, in the English system, we commonly use degree Fahrenheit. Here are the conversion equations for temperature measurements for between the three scales. For now, this is FYI. In a couple of sessions later, you will be asked to memorize these equations. For now, it's just more like, okay, here they are. Let's get familiar with them.